everyone. Welcome to part 2 of exponent laws. We're looking now at the last 3 laws, Law 3, Law 4, and Law 5, that deal with powers in some type of an operation. So far we've looked at what happens or how we deal with questions where we have 2 powers being multiplied and the base is the same. And we've looked at how to handle a question where 2 powers are being divided and the base is the same. We're now going to look at law 3, which is when we have a power, like for example a to the m, or maybe 2 exponent 3, and that power is being raised to another exponent. Okay, these are really quite easy questions to deal with. And the exponent law here is a little different. We don't add m and n together. Okay, instead, if you have a power raised to a power, we're going to multiply m times n. Another way of thinking of that is that little bracket that separates the m and the n, or separates out your exponents, is telling you to multiply them. Okay, so this little bracket here, this is just a sort of a cheating way of thinking about it, but this tells us that we're going to multiply. We're going to multiply those exponents. So we get, our answer will be a to the m times n. So we're going to multiply those numbers and it'll give us a new one. Let's talk about where that exponent law comes from, because I do like to show you the reasoning behind these shortcuts. So let's look at this question right here. So we have 2 cubed. Okay, so this 2 cubed right here. Okay, this is our power and it's being raised to the exponent 3. Well, another way I could show that is that 2 cubed is being used in a multiplication 3 times. In other words, 2 cubed is being multiplied by itself 3 times. Okay? So that's 2 cubed times 2 cubed times 2 cubed. Now, I could also write each one of those factors as 2 times 2 times 2, because 2 cubed, this right here, okay, is equal to 2 multiplied by itself 3 times. So we could also write that like this. That's 2 times 2 times 2 times 2 times 2 times 2, okay, times 2 times 2 times 2. Well, let's go ahead and count up how many 2's we have, because now this is a really simple example of our first law, which is, some number being multiplied by itself, okay, with the same base, which is 2. Well, how many times is 2 being used in a multiplication here? If we count them, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 2 to the exponent 9. That's the same as 2 used in a multiplication 9 times. So coming back to the exponent law, again, this is not a really great way to solve a problem because it's very time consuming. Instead, we use our exponent law, which is that if I have 2 cubed, I can multiply those exponents that are separated by a bracket. And I get 2, okay, 3 times 3. And the answer is 2 to the exponent 9. Okay, let's go ahead and try some more of these questions. So the next one I have down below is 5 squared raised to the exponent 3. This is the same as 5, and I'm going to multiply 2 and 3. So we just go ahead and multiply those exponents, and 2 times 3 is equal to 6. So this is equal to 5 exponent 6. Let's do the next one here. Again, if you have that negative exponent there, that's okay. Go ahead and use your exponent law. We can always deal with a negative at the end. So I'm going to multiply those exponents. So I get 4, base 4, okay, 3 times negative 2. Well, 3 times 2 is 6. And because the 2 is a negative, I'm going to have 4 to the exponent negative 6. A negative number times a positive number always gives me a negative answer. So 4 to the exponent 6 is my answer. I don't like to write an answer with a negative exponent, so I could write 4 to the exponent 6 by flipping it and making it positive. So remember our negative exponent rule. If you have a negative exponent, okay, you're going to move that base down below, and you're going to change that 6 to a positive 6. So there's my answer. Good, let's do one more. Here I have my base is, here's my base, because it's all in brackets. Okay, so when I have brackets, that exponent 2 is applying to everything inside the brackets. And on the outside, I have another set of brackets, and I have a exponent 3. So I have a power raised to a power. This is just like this, except instead of a 2, I have a 4x. Okay, so I'm going to multiply those exponents. So we're going to keep our base the same, keep it in brackets, 4x. And on the outside here, I have 2 times 3. Well, 2 times 3 is 6. So I get 4x exponent 6. And for now, we're going to leave our answer just like that. Let's not worry about how we go any further. We're just going to stop there. Okay, so this is a power raised to a power. That's our third exponent law. Okay, the last two laws that we're going to look at, Law 4 and Law 5, deal with situations where we are we have two powers or two bases that are not the same. So up to now we have looked at like a problem like this, you know, a to the n divided by a to the m, where the base is the same. Okay, now what we're really looking at is we're going to look at some dealing with some fractions where the number on the top is different from the number on the bottom. Okay, so again, these are really simple laws. And we've actually seen some of these rules before. Okay, we've sort of been introduced to them already a little bit. Okay, so law number 4 is called the power of a quotient. A power of a quotient is when you have division. So when you have A divided by B, the answer to that would be the quotient. Okay, and so these can also be looked at as you know, the power of a fraction. That would be another way to think of this. And so what we have is that when we have, let's say, some number like 1 over 4 or 2 over 5, okay, as our quotient here, and it's all raised to the exponent n. So we have brackets around this, and there's exponent n on the outside. That exponent is being applied to everything inside the brackets. So we can get rid of those brackets and write this as a to the n divided by b to the n. Okay, so that exponent is simply just going to apply to everybody inside. So let's do an example of this. So we have 2 over 3 exponent 2. Okay, I'm going to apply that exponent to everybody inside the brackets. So I'm going to get 2 exponent 2 over 3 exponent 2. Okay, and to give you an idea of where that's coming from, really, you know, 2 over 3 squared could also be written like this. All right, my base here is 2 over 3, and I'm just using it twice in a multiplication. So I'm squaring it. So on the top I have 2 multiplied by itself, which is 2 squared. And on the bottom I have 3 multiplied by itself, which is just 3 squared. And I could go further and say that's equal to 4 over 9. Okay, at this point I'm going to take us a little bit further. So what we're going to do now is say, okay, we've written this now as a power over a power. Let's go ahead and now solve this. So you can use your calculator or do it in your head. 2 squared is 2 times 2, which is 4, over 3 times 3, which is 9. And if you can reduce this fraction into lower terms, you do. You go ahead and do that. But in this case, I can't divide 4 and 9 by any other number except 1, so I leave it like that. Okay, let's do the one below here. We've got 1 over 5 to the exponent 3. Again, that 3 is outside the brackets. I'm going to apply that exponent 3 to both the 1 and to the 5. So I get 1 cubed over 5 cubed. And I want you to go further now, and I want you to figure out what is 1 cubed. Well, 1 times 1 times 1 is just 1. And on the bottom, 5 exponent 3, 5 times 5 is 25, and 25 times 5 is 125. And there's my final answer. Okay, let's do the next one. Again, I see here that I have something on the top. My numerator is different from my base on the bottom, and I'm going to just apply that exponent 4, okay, to the top, and also to everybody who's on the bottom here. Okay, so I'm going to rewrite this like this. This is y to the exponent 4 divided by 2x's on the bottom, okay, but all of that, that whole value, 2x, is going to be raised to the exponent 4. So I'm going to put brackets around the 2x there. Okay? And at this point, we can leave it. In a moment, we're going to talk about what we do with this 4 on the outside. Okay, so for now, this is fine. Okay. The second to last law, law 5, is just like law 4. They could almost be the same law. They're both telling you that when you have either a quotient or a product raised to an exponent, you're simply just going to apply that exponent to everything inside the brackets. Okay, so just like here we had a over b, okay, raised to the exponent n. Here now we have a times b instead of a divided by b raised to the exponent n, but really the law is the same. Okay, we're going to use this exponent on the outside and we're going to apply it to everybody inside the brackets. So we get a to the n times b to the n. A and b are still being multiplied together. Okay, so we don't change that. It's still a to the n times b to the n, but we can just show that exponent now being applied to both of those factors, a and b. So let's go ahead and do that. So now we can deal with just about every type of question with this law. So here we have 2x squared. So up until now, we haven't dealt with this situation, but now what we can say is, this is the same as 2x times 2x. Okay, so if I were to do that multiplication, 2 times 2 is just 2 squared, okay, which is 4. And x times x is x squared. X times itself gives me x squared, and so I get 4x squared as my answer. Okay, and so the shortcut here tells me just to go ahead and take that exponent 2 and apply it to everybody inside the brackets. So I get 2 squared times x squared, which is 2 squared is 4, and x squared can't be simplified any more than that, so I get 4x squared as my answer. Okay, let's try the one down below, 3y cubed. Again, I'm going to apply that exponent 3 to everybody inside the brackets. So I get 3 cubed times y cubed. And 3 cubed is 3 times 3 times 3, which is 27. And you could always check in your calculator. But 3 times 3 is 9, and 9 times 3 is 27. And y cubed just is left like that. Okay, I can't simplify that anymore. A little bit trickier question down below here. Okay, here I have xy to the power of 4, okay, all raised to the negative 3. So this is actually using more than one exponent law, but we can still deal with this outside exponent, and I'm going to apply that negative 3, okay, to everybody inside the brackets. So we're going to get x to the negative 3, okay, times by, well, let's have a look here. We've got y, so we could put that in brackets, times by y. Now, the y had an exponent 4 on it, and I can't forget about that. So I have 4 times negative 3. Okay, so another way to show that is 4, okay, like that, 4 times negative 3. So let's simplify that. We get, from that we have x to the negative 3 times y. What's the new exponent on the y? 4 times negative 3 is negative 12. Okay, so there's my answer, but I don't want to leave it with a negative exponent. So I'm going to reverse or flip my, my base and make that exponent positive. And because they both have negative exponents, I am going to flip them both to the bottom. So I'm going to get 1 over y cubed. So remember that, sorry, x cubed. Okay, remember that negative exponent just tells you that that base, that whatever that exponent is attached to, that whole thing should be on the bottom. Okay, or if it's on the bottom, it should be moved up to the top. Just tells you it's in the wrong place. And now we have y positive 12 on the bottom, and that's my final answer. It's a little bit more of a tricky question. that's it. I'm going to deal with some more challenging questions in just a moment, so just bear with me. But here's a summary of all of the 6 exponent laws. So the first one is multiplying powers with the same base. When you have the same base, you add the exponents. Dividing powers with the same base, we subtract the exponents. Okay. When we have a power raised to a power, that little bracket tells us to multiply the exponents. Okay, and when the last two that we just looked at now, when we have an exponent on the outside of brackets, we raise everything inside that bracket to the same exponent. Okay, so over b to the n is equal to a to the n over b to the n, and a times b, okay, power of a product, can be written as a to the n, b to the n. So I just apply that exponent to everything inside the brackets. And the very last law that we already dealt with earlier is that any power, okay, or any base raised to the exponent 0 is equal to 1. So this we have to know as well. Let's just quickly look at some slightly more difficult questions where we have to use more than one exponent law. So when you're applying more than one law, there is more than one route that you can take to solve the question. So I'll just show you a couple. And again, this is kind of like trigonometry, where there's more than one way to solve a right triangle. There's not a particular process that you have to follow here. There's more, whether you use one law first or second, we'll still be giving you the correct answer. Okay, so let's have a look at this. What I have here is 2 exponent 4 over 2 exponent 6, all raised to the power of -3. So what I could do is I could start inside the brackets, and I could recognize that inside the brackets, this is just the rule a to the m over a to the n, which is equal to a to the m minus n. In other words, I have the same base, right? 2 and 2, same base. So I could just subtract the exponents. So I could start inside the brackets, and I could say, okay, well, that's the same as 2, base 2, 4 minus 6. Okay, I'll keep that -3 out here. But if I work down the page here, let's do that. Well, 4 minus 6 is -2. So I can just simplify that exponent. And I still have this -3 outside. Okay, so let's go ahead and now multiply those two exponents. Now I have a power raised to a power. And when I have that little bracket separating out the exponents, I multiply them together. So now I have 2, and I can get rid of the brackets. -2 times -3. Well, what's the product of -2 and -3? 2 times 3 is 6. Negative times negative becomes a positive. So it's 2 exponent 6. That's my answer. And again, I could go a little further here if I don't want to leave it as a power. And I could say, what is 2 times 2 times 2 times 2 times 2 times 2? 6 times 2 exponent 6. Do that one. That's a big number. Let me think about that one for a minute. I'll have to check it on my calculator. Oh, it's 64. Not that big. Okay. Okay, 64 is my answer. Let's do another one here. Slightly different question. Inside my brackets, I have the same base being multiplied. Okay, so right here, this is just law number 1. Okay, a to the m times a to the n. And when you have the same base, you add the exponents. And then on the outside, I will end up with a power raised to a power. And I'll have to take into account that outside exponent. So if I go ahead and start inside the brackets, which is a good place to start, although you don't have to, and I'll just show you in a minute how you could solve that without doing that. Inside the brackets, then, I have base t, and I'm going to add the exponents. So it's -4 plus 3. Okay, and I'll keep that -3 on the outside. I don't want to forget about it. So now inside the brackets, I have t. Well, let's see, -4 plus 3 is -1. So I have -1, t to the -1, all raised to the power of -3. So I have a power raised to a power. This is law number 5. Okay, so I multiply those two exponents, and I get, this is t. Well, -1 times -3 gives me +3. So my answer is t exponent 3. I just want to show you for a moment that you don't have to solve it from the inside out. So we could have also looked at this question and said, well, I see that inside my brackets, I have more than one factor here. So you could have started by multiplying that negative 3, or pardon me, applying that outside exponent to everything inside the brackets. So we could have also said this is going to be t, okay, to the negative 4 times negative 3, okay, multiplied by t to the 3 times negative 3. So we could have gone ahead and started with the outside exponent, and we would have gotten, well, inside, let's see, negative 4 times negative 3 is positive 12. So we would have got t to exponent 12 times t to the negative 9. 3 times negative 3 is negative 9. And then I would have simply said, okay, I've got two powers with the same base. I can add the exponents. So 12 plus negative 9, which is going to come out to be, that's 12 minus 9, which is 3. Okay, so more than one way to solve that problem. But generally, it's a good idea to work from the inside out. It usually simplifies the process for you. Okay. One or two last difficult questions for you. Again, these are putting more than one law together. Let's have a look at this one here. I would, again, like to work from the inside out, but I see that I have a y here and a y here. Okay, now I could look at this and say, again, there's more than one way to do this. So one route is to go ahead and multiply those exponents on the top first. So let's get this to be just one power on the top instead of a power raised to a power. So 2 times 0 is 0. So I get y to the 0 over y cubed, okay, to the negative 3 on the outside. And so at that point, I could say to myself, well, I am now going to raise everything inside the brackets to the exponent negative 3. Okay, so I'm going to get on the top here, that's 0 times negative 3. And on the bottom, I have y 3 times negative 3. Okay, this is one way of solving this. And from there, let's see, what do I get on the top? Well, 0 times anything is still 0. So y to the 0 on the top. On the bottom, I have y to the negative 9. Okay, and y to the 0 is equal to 1 over y to the negative 9. And I don't want to leave my answer with a negative exponent, so I could flip that y up to the top and write it with a positive exponent. So it's now y to the 9 times 1, which is just y to the 9. That's one method. Another method that we might have used to solve this problem is to, again, work from the inside out. So we could multiply the 2 and the 0 so that we get y to the 0, okay, over y to the 3, all raised to the negative 3. And then we could have simplified inside our brackets. We could have recognized that we have the same base, y and y. And when I'm dividing two powers with the same base, I can subtract the bottom exponent from the top one. So this is the same as y 0 minus 3. Okay, all raised to the negative 3. And that can simplify to, well, 0 minus 3 is just negative 3, y to the negative 3, times negative 3 on the outside. Multiply those exponents, and we get y to the power of 9. And as it turns out, that's actually a bit of an easier method, okay, to use. So again, working from the inside out is a great way to do it. Let's do one last example together. Again, this is a power raised to a power raised to a power again. So just work from the inside out, okay? I can't simplify what's inside my brackets any more than that, so I just leave it, okay? But I can raise everything inside the brackets to the negative 3. So let's go ahead and do that. So we get x to the negative 3 times y, and I have to multiply that 4 and the negative 3 together. So I get 4 times negative 3 is negative 12. So I've taken care of the first exponent outside the brackets. Now let's take care of that -2 that's outside the brackets. Again, okay, you're going to raise everything inside the brackets to -2, which means you're going to multiply them. Okay, this is a power raised to a power. This could also be written like this. Okay, I could also look at it like that. That's the same thing. Okay, and so I'm going to get -3 times -2, which is +6, so it's x to the power of 6. Y, -12 times -2 will give me +24. They're both positive, so I go ahead and leave my answer just like that. I don't have to flip it. Okay, and it turns out I got rid of all those negative exponents in the end, so that's great. I'd like you to try your worksheet number 2 now. So this is worksheet, exponent law worksheet. Okay, exponent law worksheet 2. You can ignore, pardon me, hopefully on your notes it doesn't say that. You can ignore the textbook questions here and just go ahead and try your worksheet. Check your answers, please, and best of luck. Thanks for joining me. Bye for now.